Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. So today we are going to talk about the law of sines. So we have two sessions today. We are going to talk about the law of sines, and tomorrow it will be the law of cosines, and then we'll see how we use them in conjunction to find anything we need about any particular triangle. And it's so easy. All what it says is if you have a triangle, let's draw a triangle. It's not the best pencil, but okay. If we draw any triangle, okay, it doesn't matter if it's right, acute, obtuse, scalene, it really doesn't matter. And let's call it ABC. And then the side opposite to every angle is named the same letter, but we usually use a lowercase letter for the side. So this would be A, this would be B, and that would be C. All what we know is, that the sum of these three angles is 180 degrees. If you give me enough information, maybe you give me, say, an angle and two sides, I can find the other two angles and the last side, and so on and so forth. And the equation that relate any triangle or the angles and the sides of any triangle is as follows. If I divide the sine of A but by the length of the opposite side, I get a constant value that is the sine of the B divided by the opposite side equals the sine of C over the length of the opposite side. Okay. Alrighty. So what is this value? It turns out that this value or this ratio is exactly equal to the diameter, oops, of the circumscribed circle. Meaning, if I find the center, the circumcenter of this triangle, you know how you do that, right? You go to the midpoints of each side, and then you draw a line perpendicular to it. These three lines, these three perpendicular values that bisect the sides, so you'll always intersect at a point. And this point, let's assume it's here. I'm not going to waste time drawing it. If I draw a circle, it will pass through these three heads. Okay? And then the sine of A over A or the sine of B over B would be the length of the diameter of that circle. Again, I don't think you will need it in this course, but it's something to know. So now we have a bunch of problems where we are going to give you some information and ask you to find the rest just by applying that. So it's pretty straight easy. But not only that, we can use, once we know this information, I can find the area of the triangle. I can use the area of the triangle using these values, or by Heron's theorem, if you know what that is. I think some of you already know that. But in this course, I can draw a perpendicular from any line, from any head. So usually you will draw it from A, but you can drop it from B or C, it doesn't matter. It would be the height of this triangle. Let's call it H. So in this case, the area of the triangle is A times H over 2. You say, no, it's BH over 2. Yeah, I know. B is the base, but this base is A, okay? No memorization. Just base times height over 2. Of course, I'm just kidding. I know you know that. And you said, but I don't know the height. Yes, but don't you know the B and C? And you know the angle C and the angle B? So in say in this triangle, can I get a relationship between the sine of this angle and these? Oh, the sine is opposite over hypotenuse. So sine C, which is this one, which we already found, equals h over b, which means if I multiply both sides by b, I get the height of the triangle is this side times the sine of the adjacent angle. By the same token, I can say, no, it's C times the sine of B. And since I know this height now, I can say A, B sine C over 2 or AC sine B over 2. And that's basically what we need to cover in this part. One small thing that I want to draw your attention to is that sometimes if I give you values of maybe a couple of sides and another angle not between them, okay? They may be two different triangles that fit those values. I know it's a little confusing, but if you remember that sine of any angle A equals the sine of 180 degrees minus A, right? Because this is in first quadrant, this is in quadrant 2, and the sine is positive in both 1 and 2. So let's see that in some of the problems you are going to encounter. I have like, oh my God, these are how many? Ooh, there are 28. No, definitely not. So I don't know. Last time, I think. Let's do 2 and that, and maybe that, 7 and 10. So 4 problems here. They are identical, so it's a waste of time to keep doing the same thing over and over again. Here they say solve each triangle and round your answers to the nearest 10th. Oh, so here they only wanted one angle. Here they want everything. So side B and angles B and C. So let's do a couple of those. Let's say 13 and 16, for example. Here they say state of number of possible triangles. We'll talk about that. This I just barely mentioned using the given measurement. So let's do 21 and 24. And here find the area of these triangles. So let's do 26 and 27. That's too many. I think we have like 10 problems. So they need to find side AB. Very good. I don't know what AB is, but I know that AB divided by sine, the opposing angle is 35, equals 7 over the sine. We could have done the sine on the numerator or the denominator. It doesn't really matter. I just wanted AB to be on the numerator, but it really doesn't matter. Sine of 44 degrees. Make sure your calculator is in degrees, not radians, because if you're drawing or graphing uh, uh, the sine and the cosine or the trig functions, usually we use radians. So be careful and make sure you switch back to degrees before you solve that. So there is no reason to keep writing the equation. I know that AB, if I cross multiply, it would be 7 sine 35 divided by sine 44. 7 sine 53, I said 35, divided by sine of 44. Since sine 53 is greater than sine 44, I expect AB to be slightly greater than 7, right? The sine goes from 0 up to 1 when I reach 90 degrees. So it keeps increasing in the first quadrant. Again, why I'm saying that? Because if you click the wrong button and you end up with a value that is smaller, you say, oh, I must have done something wrong. I got 8.05, nearest 10, so 8.0. Let's do the next one. Again, I don't see a reason to do many of those. But this is important. You see, this angle is 101. It's the same as the sine of 79. You see, sine of 101 and the sine of 79. Same exact value because they are supplementary angles. Any two angles that add up to 180, their sine would be the same, but not their cosine. Their cosine would be the negative. Anyway, but the plus theta and minus theta, the cosine would be the same because first and fourth quadrant. Again, don't worry about that. You will learn a lot of these later. Now, in this one, they want the length AB. We have a problem. AB, or if I say, well, I prefer to write the side on the top if they ask for the side. So instead of being in the denominator and then it's not harder, but or not easier, it's the same thing. I just want to let you know that don't be very fixed on saying if someone tell you, oh, it's A over sine A equals B over sine B, you say, no, 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 it's sine A over A equals sine B over B. That's what I don't want you to do. To understand that we have flexibility in math. As long as you're not doing something wrong, even if it looks weird, it may be correct. If you can justify it, if you can say, well, I did this, this, and that. Anyway, so I'm going to divide AB by sine 63. But if I want to divide the 9, because I have a 9, is over sine of what? They don't give me the angle. Yes, because they know you are a good student. And you know that the sum of these three angles is 180. So if I add these two, I get 164, which is 16 away from 180. And now it's the same thing. 9 sine 63 divided by sine 16. Again, sine 63 is much higher than sine 16, so I expect AB to be larger than 9. Of course, I get 29.1 units. I don't think there is anything harder than that. Find angle C, the measure of angle C. I only have one angle, but I have all three sides. So I can say, let me do it sine over the number instead of number over the sine, even though it doesn't make any difference. And I don't know this guy, so I'm going to say sine of C. That will not give me C, it will give me sine of C. So how do I find the angle? Let's find out. So sine C here equals, if I do a cross multiplication, 20 times sine 82 divided by 29. 29 is larger, right? And I got this value. But that's not the angle. That's the sine of the angle. Of course, we have what we call inverse trig functions. I think we'll cover that in detail in pre-calc. So you see the button that says sine. If you click second before, it will give you the inverse. Excuse me. Meaning if I enter a sine value, it will give me what angle makes that. So I'm going to say second inverse sine of this value. What angle would produce that sine? I get 43.1 degrees if they want me to use to the nearest tenth. 43 degrees. Okay. 43.1. Find again the measure of angle C. So I would say 19 over sine C equals 22 over sine 97 or sine 83. Any two angles, as I said, if they add up to 180, you can use them. So I can get sine C first. 19 sine 97 divided by 22. No, yeah, correct. So I get 0.87, 0.857. I take second inverse sine of this value. So C equals 59 degrees. So do you see how easy it is? Oh, I'm sorry, here C equals 43.1 degrees. This value was 0.68, 0.6829. I'm sorry. Okay, so far so good? I hope so. Go to the second page. We have 6 problems here. Again, solve each triangle, meaning find everything that's missing. Okay? So they give me angle C and they give me C. So I can say sine B over 7 equals sine C, sine 145 over 33, that's the opposite side, equals sine A over A. And you say, how can I find this? Yeah, we'll find it. Of course, you know why. Because once I find sine B, I can find angle B. B plus C plus A is 180, so I can find A, and finally I can find the measure of A. I'm going to use the rest of this side to complete the problem. So first of all, I'm going to say sine B equals, and then I get B equals. And then I would say A equals, because I can find the angle. Oh, I'm sorry, I wrote over A as an angle, not as side. And then A equals. So I have to find 4 things. The first thing is very easy, right? To find sine B, I'm going to multiply 7 sine 145 or sine 35 divided by 33. Let me clear this. Clean the screen. So 7 sine 145 divided by 33. 0.121. I don't care to write it in how many decimal places because I have it here. So all what I have to do is to say second inverse of that. I could have done that in a single step, by the way. 6,992 if I nearest 10. So 6.99. No, 7.0. It's nearest 10th, not 100. Okay, so I found that. Then I would say 180 minus 145 minus the angle B, which is the angle B, which is 6.9888 equals, I get 28. So this angle is 28. And then if this angle is 28, to find A, I'm going to say, for example, 33 sine 28 over sine 45. 28 sine. Oh, I'm sorry. I said 28. No, it's 33 sine 28 divided by sine 145. So that gives me 27 units. If I use sine B over B, would I get the same result? Absolutely. If I want A, I can say 7 sine 28 divided by sine B, which was the 0.121 up there. 27.1, of course. Just so that you understand that. This is the same thing. We have B, so I know these two are opposite to each other. So I start by saying sine 84 over 9 equals sine A over 18. I can solve for A right away to save time. So what I'm going to say is inverse sine of what? Of 9. I'm sorry, 18 sine 84 over 9, which is just 2 sine 84, right? 2 sine 84 degrees. You see what I'm saying? It's because the 18 is twice 9. So instead of saying times 18 divided by 9, it's just times 2. Oh, quit. I did something wrong. Yeah. Okay. Okay. Of course it's wrong. Because I multiplied inside. Oh my God. How did I do something that dumb? Okay. So it's inverse sine 18 sine 84. I didn't uh over. No, that doesn't make sense. This number is greater than 1. This one, there is no value. This is not a triangle. You see what I'm saying? If I want to find sine A, the only time I said let's do it on a single step, oh my God. So I say 18 sine 84 divided by 9. This value is greater than 1. What? Can the sine be greater than 1? The sine and the cosine, their minimum is -1, their maximum is 1. If I do this, I get 1.99. So these values cannot support a triangle. I can never have a triangle with these values. So no value, no triangle. Of course, if these numbers work, I could have done it on a single step, but no. Okay, here it's a little tricky. It says state the number of possible triangles. What do you mean possible triangles? I can have 0 triangles that fit these values like we saw here, or I can find a unique value for that triangle, or I can have 2 triangles just because I told you when you divide and you get the inverse sine, and I say inverse sine of theta or A or whatever is 1/2. The sine of theta is 1/2. So the inverse, the calculator will give you 30 degrees. But then you say, wait a second, it's either 30 or 150. So you may have 2 triangles that fit the same thing. One of them is acute, the other is obtuse. So let's do these 2. You get a piece of paper. Then I have a blank one here. Okay, so the first one, they give you the measure of angle B is 29 degrees, A is 14, B is 19. Okay, so I'm going to say, first of all, I say sine of 29 over 19 equals sine of A over 14. So if I want to solve for A directly, and this time it's going to work, don't worry, I'm going to say inverse sine, and then I'm going to multiply these 2 over that. So 14 sine 29 over 19. I divide by 199, I think. Oh my God. I have to do something wrong. Okay. And I get this angle is 20.9. Did they say? Oh, no, they not working. Okay. I'm sorry. This is the angle. And you say, no, it may be 20.9 or it may be 180 minus 20.9, which is roughly 159, right? 159.1. Wait a second. If this is 151 and this is 29, they add up to 180. So what about angle C? It's impossible. Again, this angle, I say this or 180 minus that. So this angle is 159. So or 159.1 degrees. But if it were 159.1, I'm going to add to it this angle. Oh no, it's 188, which is greater than 180. So I said no, only one triangle, only one. I can't have two. Notice I'm not changing the 29 because they said this is fixed 29. So I'm not going to say 29 or 180. No, it's given to you. They say we measure this angle is 29. We measure these two values. Let's go to number 24. So this is 21. This is 24. The measure of angle B is 35 degrees. A is 24. B is 6. Wow, that's so small. Sine of 35 over 6 equals sine of A over 24. That won't work. Because sine 35 is more than 1/2. Do you know that sine 30 is 1/2? So let's assume even it's a half. A half times 24 is 12, and 12 divided by 6 is 2. So sine A would be roughly 2, which is impossible. But let's do it. Inverse sine of 24 sine 35 over 6. And we get error because the inverse sine cannot be that. Okay? So no triangles. Oh my God, we didn't see how we can have two. So let's pick another, I don't know which one. So let's try it from the beginning. This doesn't seem, I don't know if that would be on. Let's do this one. This one seems, because this is larger than that, so this angle would be slightly larger. Would be, so the the supplementary angle would be smaller, so maybe it works. Let's see that. We can say sine 29 over A, which is 17, equals sine C over 18. So from here, we can get angle C, okay? And this would be inverse sine 18 sine 29 over 17. So this angle is 30.9 if we use one decimal place like that, or 149.1, or 180 minus that. Well, if it's 30, there is no problem because 30 plus 29 is 59, so the other angle is 180 minus that. But what about 180 minus that? Of course, the difference would be smaller than the supplementary of that. I don't know if you got what I meant. I can say this plus 29, it's very close to 180, but still feasible. I can have a triangle whose one of the angles is 107, is 149. And maybe it's from here. And this angle is 1.9, and that angle is 29. And this is 149.1. So these add up to 180. It is possible. Okay, or you have a triangle whose this is 30, this is 29, and this has to be large, right? I didn't, so that would be roughly one, this is a 121. It really doesn't matter. They don't want you to draw it, but you see that we can have two cases. So when you get an angle, you say, oh, it may be this or 180 minus that. And then you check if it's 180 minus that, would that make a triangle, or the sum of these two would be greater than 180, which is impossible. Okay. So in that case, you say only one triangle. And sometimes you don't get any triangle that fit these values. Okay, now we have a triangle. They don't tell you this is 90 degrees. This is a common mistake. Of course, in this case, it doesn't matter, but unless they show you a square here, if they do that, it means 90 degrees, or if they write on it, it's 90 degrees. Otherwise, you cannot assume that. So this angle, oh, I'm sorry, this is R, this is Q, this is P, 6.7 kilometer, 7.6 kilometer, and 28 degrees. You can, it doesn't matter. You can think of it either way. You can say this base times that height over 2, or this base times that height over 2. So let's say this one. So this is the height. So we say the area of the triangle, area equals 1/2. I'm going to use the base is 7.6, and the height is this sine that times 6.7 sine 28. 1/2 times 7.6 times 6.7, and which you like, I know, sine 28. And that would be 11.95 square kilometers. Don't forget the units. You can lose points. You do. And that is number 26. We said we are going to do number 27, and that's enough. I think we covered everything here. 27 is giving you a triangle for 7 miles. And, oh, I'm sorry, 4 and 7 miles. Yes, it's correct. I confused. Said which one? P, and this is 36 degrees. Again, if I drop a line here, yeah, I can do that. Perpendicular, then this value is 7 sine 36, because 36 is opposite over hypotenuse. So if I multiply the hypotenuse by the opposite divided by the hypotenuse, they cancel each other and I get the opposite. So it's 1/2. Oh, I'm sorry. We cannot do that because we don't. Yeah, it's 1/2 times 4 times 7 sine 36. But I can do it also. I can say this guy, and it's 7 times 4, that's sine 36. It's the same thing, except that I commutated, like I did a commutative 4 times 7 or 7 times 4. It doesn't matter. And this is 14 sine 30, right? 4 over 2 is 2 times 7 is 14. So 14 sine 36. And that gives me 8.2323 square miles. And that's it. Okay. So that leaves us with only one remaining session on the law of cosines, which I will go over with you next session. And we will see how we can combine these two to find stuff that cannot be found only using one law, okay? Because sometimes I don't give you all this information, okay? I give you maybe some of those, but you have to use the law of cosine to complete it, as we will see. I think that's it for today. And as usual, feel free to comment on anything that you don't see that makes sense to you, or you think it's not correct, and I will get back to you as soon as I can. Thank you very much for watching, and I hope to see you soon. Bye.